So section 10.3 talks about equations that are quadratic in form. So the big thing to understand is what makes an equation quadratic in form. And there's kind of a pattern amongst the exponents that makes equations quadratic in form. You can see that in each one of these. Not as obvious here because there's no exponent written for the first one. It's understood to be a 1. And the pattern is that the middle exponent is half of this one. Or double this gives you this. 2 times a half gives you 1. 2 times 2 gives you 4. So when your exponents have these patterns, your equations are quadratic in form. Down to this one. 2 times 1/3, oh, that's 2/3. Or half of 2/3, that's 1/3. But in each case, we're going to kind of temporarily make these equations look like quadratic equations. And then solve the quadratic equations and then work backwards. Because in solving the quadratic equations, eventually you're going to be factoring. And when you factor, that kind of splits things up. And then all of a sudden you just have a linear equation. That's a lot easier to deal with. But let me go back and discuss how we're going to do this kind of trick. And the trick is, when you have an equation that's quadratic in form, that the exponents satisfy this, you're going to let u equal the middle term, just the middle variable term. You're not going to worry about the coefficients at all. That could be negative 7x to the half, or it could be plus 5x to the half. You're just taking the middle variable part. Once you do that, u equals that. If you were to square both sides of this, you're going to get this equation, u squared equals x. And that x term should be your leading variable. With that, you're going to rewrite this equation. Instead of the 2x to the first power, I can write 2u squared, because x is u squared. And then instead of x to the 1/2, I'll just write a u. That gives me an equation that we're more familiar with. That's a quadratic equation. Now below that is how you factor this and set it equal 0. So let's just skip down to kind of like the happy ending part of it. This part where you've got something times something else equals 0. So one of these somethings has to be 0. Either u minus 1 equals 0, which gives me u equal 1, or 2u plus 1 equals 0, which gives me u equals negative 1/2. Now I'm not done solving here yet, because remember my original equation was an equation in x. So now I'm going to go back and say, all right, well, this was really x to the 1/2. And okay, I need to get x by itself. You might remember that x to the 1/2 is the same thing as the square root of x. And to solve for x, what do I do on both sides? What can I do on both sides?
Square them.
Square them. Perfect. Square them. And when you square them, this cancels and I get an x. 1 squared is 1. All right. Let's do the same thing here. Except this time I want to do it, I'm not going to write it as the square root of x. I'm going to leave it as x to the 1/2. And I want to show you another thing you can do, or another way you can think about solving these things. A nicer general way to think about solving these things. And that is, I want to raise both sides to the reciprocal power. So what do I mean by that? Well, here's my exponent of 1/2. What's the reciprocal of 1/2? 2. So I'm going to square both sides. Now watch. When I remove the parentheses, these exponents multiply. 2 times 1/2 gives me 1. So that's x to the first power, or just x, equals 1. And you're done. Yay. Not quite. I wish we were done. Technically, because you're squaring both sides of an equation, you have to go back and check your answers. you have to go back and check it in this equation right here. Remember, something to the 1/2 power is like the square root of a number, so that's the square root of x. If I put this in my solution, if I try to check it, does the square root of 1 equal -1? So if I try to check this in this equation, does the square root of 1 equal -1? No. So that's an extraneous solution. Bummer. You know what? Oh man, I made a mistake here, didn't I? Should have had this equal to -1/2. Oh, I feel so bad. It's still going to work out the same way. If I square both sides, I get 1/4. And I take and check my solution. Does the square root of 1/4 equal -1? And the answer would be no. Or -1/2. It equals +1/2. So it doesn't work. The bottom line is that when you square both sides of an equation, you have to go back and check your answer. That one doesn't check. This one does check. Kind of a different way you can see, you know, how many solutions to expect, at least real solutions, is to look at the graph. I think there's somebody that was going to ask a question there, though. Go ahead.
Yeah. If you on our exams, when we come to problems like this where we end up having to square both sides, are we going to have to write if it's extraneous or not?
You don't have to write it's extraneous or not, but what I'd appreciate is if you draw like a line through the solution that is extraneous, just to let me know I've checked it. It doesn't work in the original problem, so it's an extraneous solution. Something that indicates to me that you understand that, hey, this one doesn't work. So.
Gotcha. Okay.
All right. Appreciate that. Well, let's take a look at the graph of this. So kind of like what I did with the last section, I'm going to take and graph y equals that mess. All right, right here. And let's just see what happens. So let's see. I think I got that one right here. Notice that the graph only crosses the x-axis at one place, and that's at 1. Now you can kind of zoom out a little bit if you want and see that that graph's not coming back. It's not going to come back and touch the x-axis anywhere else, so there's only one solution, and that's at x equal 1. So nice. Let's take a look at this one. How many solutions do you expect from our next problem? Look at the line y equals 0. Yeah, right here. 1, 2, 3, 4. So just looking at the graph can tell you how many solutions you expect. But let's actually see if we can't find those solutions. So, like a lot of our problems, you're going to start out by moving this term to the other side to get 0 on one side. You can make your u substitution because this is quadratic in form. So we'll let u equal the middle variable term. I'm not doing anything with the 15. I'm just letting u equal that middle variable term. And then automatically u squared is that term. That allows me to do my substitution, factor, and solve. Now notice you factor out the GCF first, and then what's left will factor pretty nicely. That's just two numbers that multiply to 4 and add to -5. I get two solutions, 4 and -1. Keep in mind, we got to go back and finish solving these for x. So you say, oh, well, u was really taking the place of x squared. So I get x squared equals 4, or x squared equals 1. The easy thing to forget in doing these is to take the plus or minus. I want to take plus or minus the square root of those. So I get plus or minus 2 here, and plus or minus 1 here when I take the square root of both sides. Now when you're taking this, the square root, you don't have to check your answers like that. I mean, it's a good idea, nothing wrong with it, but you don't have to check your answers. You can still use the idea of taking and raising both sides to the reciprocal power. Let's take a look at this. What's the reciprocal of 2? Or if I wanted to, I could think of it as 2 over 1. What's the reciprocal of 2 over 1?
1/2.
It's 1/2. Now here's a little trick for you. When you're solving this, you want to raise both sides to the reciprocal power of the exponent. That works great, but you just got to keep in mind this little reminder. If the numerator of the exponent is even, then you got to use the plus or minus. So looking down here, the numerator is even. That's 2 over 1. So when I take the 1/2 power on both sides, that's where I've got to use the plus or minus. Okay. 1, maybe 2 more like this. Let's see, let's shut this one off and turn the next one on, which is this one. This graph's a little harder to get a handle on. So I put a little reminder here in your Desmos link to adjust the window so you go all the way out to 80, say. And that's good enough. I'll kind of zoom in this way. How many solutions do you think you expect on this one?
2.
Yeah, 2. Looks like it crosses the x-axis twice. So we expect 2 real solutions. You could get some complex solutions. You won't see those on the graph on Desmos. But looking back here, kind of the same thing. I hope that you're getting used to this. You've got something which is quadratic in form. This exponent is half of this exponent. So let's let our middle term be that. And then if you square both sides, you get this. That allows us to rewrite this equation as something like this. Factor and solve. Great. And let's see if we can't use the trick that I just taught you. If you wanted to solve here, you've got x to the 1/3 power. What's the reciprocal power that you want to raise both sides to solve here? What's the reciprocal of 1/3?
3.
3. So if you cube both sides, 1/3 times 3, oh, that just gives me x to the 1st power. And 4 cubed is 64. 3 cubed is 27. But you're done. Raise both sides to reciprocal power. You should check these back in this equation here. They both check. Cube root of 27 is 3, cube root of 64 is 4. So they both check. But if you wanted to check it on Desmos, and you're clever enough, you would see that it worked. Take a look here. 27 and 64. Perfect. It's a great way to check your answers. You can use Desmos on my test, but I still want to see the work. I think that's really fair. I'm giving you the answers. You just got to show me the work. So if you make a mistake, hey, no big thing. Go back and correct it. Now, Michaela had a great question about this one. So let's take a look here. And let me kind of zoom back in.
Wait,
Looks-
Mr. Parent, before we do the next problem,
Yeah.
the last problem we just did. So the only reason why the answers aren't plus or minus is because they were cubed? Is
Yes.
because we have to cube? Okay.
Yeah, so that goes back to that little bit that I put right here in the margins here. When you raise both sides to reciprocal power, you want to use the plus or minus if the numerator of the exponent is even. Now when we look down here, and it's a great question, Summer, I'm glad you helped me make this point. When you look down here, what's the numerator of this exponent?
1.
1, and that's odd. So you don't have to use a plus or minus when you raise both sides to the reciprocal power. If it was 1/4, then you would have to, or excuse me, not 1/4, but if it was like fourth root,
2/3.
something to the, 2/3. Yeah, if this was to the 2/3 power, then you would have to use the plus or minus. So,
Okay.
great question. Thank you for that. So, Michaela, let's go back to yours here real quick. This is half of this, so I'm going to let u equal x squared. U squared equals x to the 4th. This is u squared plus 4u minus 5 equals 0. That factors as u plus 5 times u minus 1 equals 0. Now on WebAssign, I think they're going to want the non-real solutions. First of all, they're not going to want solutions in u. They're going to want solutions in x. So you're going to have to go back and say, all right, well, u is taking the place of x squared. So this is x squared equals -5. This is x squared equals 1. If you raise both sides to the reciprocal power in this case is 1/2. Half. So I want to take, basically I want to take the square root of both sides. In fact, there's nothing wrong with just taking the square root on both sides. That's another way to think of this. So I want to take the square root of x squared and the square root of 1. Just make sure that you do the plus or minus. On the right hand side I get x's plus or minus 1. On the left-hand side, you get x's plus or minus the square root of -5. And you can simplify that as the square root of 5 times the square root of -1, or plus or minus the square root of 5i. It's probably a little bit less dangerous to write it as I times the square root of 5. If you actually look back at the graph, you'll notice that the only solutions we see are the real solutions. We didn't see the complex solutions. We just saw across the graph at x equal 1 and x equal -1. You're not going to see these solutions there. I do think, Michaela, you can tell me, did WebAssign want the complex solutions as well?
Yes.
Yeah. All right. So it is going to look for these two solutions in addition to the real solutions. So let's look back at the graph. Yeah, all we saw was the real solutions. But there's two more. When you're working with polynomials, and this is kind of a little hint at what you're going to see in college algebra in the next course. When you're working with a polynomial, so that these are all integer numbers, integer powers of x, that number, your degree of the equation, will tell you how many solutions you can expect. Degree 4, 4 solutions. Degree 3, 3 solutions. Degree 2, 2 solutions. So it's telling you what to expect in advance. Excellent. Any other questions? All right, good luck.